What is inheritance? Creating a new class from an existing class is called inheritance. What in a inheritance existed class is said to be superclass. New class is said to be subclass. Whenever superclass object is created, then memory allocated to superclass members only. Whenever subclass object is created, then memory allocated to both superclass and subclass memory allocated. Okay. How many types of inheritance? 6 types. What are those? Single inheritance, multiple, multi-level, hierarchical, multipath, and hybrid. Multipath, can I call it a hybrid? Multipath is also an example of hybrid. Multipath also an example of hybrid. Okay. Java doesn't support some inheritances. What are those? Multiple, multipath, hybrid. Now, why it doesn't support? I'll explain. Suppose it is A class, it is B class. This is which type of inheritance? Single inheritance. Okay, it is single inheritance. This is which type of inheritance? Which type? Multi-level. A class, B class, C class. It is multi-level. Okay. Now, you observe. Here, show method is there. Here, print method is there. If I create an object of A class, how many methods we can access? Only one method, that is show. If I create an object of B class, how many methods we can access? 2 methods, show and print. Okay. Now, here, show, print, display. If I create A class object, how many methods we can access? One method, that is show. If I create B object, 2 methods, show and print. If I create C object, 3 methods, show method, print method, display method, all we can access. Okay. Now, suppose here I'll create B object. Then memory allocated to both A class members and B class members. Okay. Here I'm calling ob.show. Here I'm creating C class object. I'm calling ob.show. Okay. Suppose here show method is there. Here also show method is there. It is called overriding. You studied overloading, overriding definitions. What is method overloading? Same name, different parameters list. That is overloading. What is overriding? Same name, same parameters list. That is overriding. Overloading possible in same class. Overriding not possible in same class. Like that you studied. But in different class, it is possible. Overriding different classes possible. Now, here show method, here show method. If I call ob.show, this is going to be called. If I don't write here, if I write only here, this is going to be called. Because with the B class object, memory allocated to A class members and B class members. Okay. Now you can access A members also, you can access B members also. Okay. Now, suppose A class also show method is there. B class also show method is there. If I call ob.show, B class show is going to be called. Now, if I remove B class show, then A class show method is going to be called. Clear? Suppose in this case, here A class contains show method, B class contains show method. Then if I call, which show is going to be called? B class. In B class, if it is not there, then A class. In A class also not there means error comes. Okay. Now, here show. Here show, here also show method, here also show method. 3 show methods are there. Okay. If I call ob dot show here, which class show called? C class. C not there, B not there. Okay. You can give answers here possible. Now, suppose here it is A class, it is B class, it is C class. Which type inheritance? This is multiple inheritance. It is multiple. A class, B class, C class. Here C OB equal to news C. OB dot show. Now, first last question, give me answer. This is which type of inheritance? Multiple inheritance. If we create object of A class, memory allocated to how many classes? Only one class A. If I create B object, only B. If I create C object, all classes A, B, and C. 3 classes memory allocated. Okay. Suppose here show method. Here also show method. Here also show method. OB dot show. Which show is going to be called? C show is going to be called. Assume there is no show method in C. What will happen? You are getting confusion, no? Compiler also gets confusion, no? Okay. You are getting confusion to give answer. But like that, compiler also will get the confusion. It is called ambiguity. So compiler gets ambiguity to call either A show or B show. Because for C class, A also superclass, B also superclass. But in this case, different. For C, superclass is B. For B, superclass is A. But in this case, for C, superclass A and B, both are having equal priority. Then ambiguity comes. Say, if the method is present in C, C is called. If not present, superclass. But A also superclass, B also superclass, both are in same level. Both are in same level, same priority. Then ambiguity comes. Say, it's like a mother, it's like a father. Select one means, can you select? Mother and father equal priority, no? Okay. Mother, father. Select one means you cannot select. Mother also important, father also important. Both are equal priority. But here different. It is father, it is grandfather. Then what will do? Definitely go to father. Okay. Like that. So here father, grandfather means definitely give a priority to father only. Okay. But here mother, father means equal priority. Like that. So this statement gets ambiguity to call. That's what Java developers removed this concept. What are the problems they faced in C++ language? Those all rectified by Java developer. They introduced new concepts. For a multiple inheritance purpose, new concept introduced interfaces. That you will study further. So this is the reason Java doesn't support multiple inheritance. Okay. Now, what you do is just you write that point. Just write that point. First, you don't write these diagrams. Don't write the diagram. Just write the point. Java does not support multiple inheritance because of, Java does not support multiple inheritance because of ambiguity. Java does not support multiple inheritance because of ambiguity. Java does not support multiple inheritance because of ambiguity. because of ambiguity. Java does not support multiple inheritance because of ambiguity. What is ambiguity? I'll give. Now this diagram, write it. Here, this statement gets ambiguity to call either A show or B show. This statement gets ambiguity to call either A class show method or B class show method. This statement gets ambiguity to call either A class show method or B class show method. This statement gets ambiguity to call either A class show method or B class show method. This statement gets ambiguity to call either A class show method or B class show method. Only multiple inheritance diagram, write it enough. So OB dot show. In this line, error comes. In this line, this statement gets ambiguity to call either A class show method or B class show method, because here no show method. In this situation, ambiguity comes. Is it over? Now, this is the reason Java doesn't support multiple inheritance. Now think yourself and give me answer. Why Java doesn't support multi-path inheritance and hybrid inheritance? This is multi-path. You can give answer. Why Java doesn't support multi-path? In multi-path also, multiple is there. Hybrid also, multiple is there. That is the reason. So just write it. Java does not support multi-path inheritance and hybrid inheritance because both types contain multiple inheritance. Java does not support multi-path inheritance and hybrid inheritance because both types contain multiple inheritance. In multi-path inheritance also multiple is there. Hybrid inheritance also multiple is there. That's what not supported. Suppose in a software company written test, if they ask Java does not support dash, option A, multiple, option B, multi-level, option C, multi-path, option D, hybrid. But you have to select only one. Which one you have to select? Multiple. Because this is also that reason only. Because this is also that reason only. If they ask question like that, you have to select multiple only. These two also because of multiple only. Okay, these two also because of multiple only. What happened? You are going to become an IT professional. See, Java does not support multi-path inheritance hybrid because both types contain multiple. Okay. So because of multiple only, these two not supported. Now, whatever you studied yesterday and this one, theory part. Now programming. Now programming we'll see. See, it is first 4 object-oriented principles are there. First, you are learning inheritance. Okay. Now, first programming in object-oriented principles. Suppose class A. Have remembered this keyword? Remember or forgot? We'll see. Now, class A, because those are required. Whatever you studied, all required. Okay. Class A. Integer x equal to 10. Which type of variable? Instance variable. When memory allocated? Which memory block stored? If I create 100 objects, how many copies created? How many ways to access? What are those? When we have to use object? When we have to use object reference? More than one time. Okay. This is which method? Instance method. Okay. Like this. Very good response. I want like this only up to last class. Okay. Now system dot out dot println. Suppose A class. It is just one class. Okay. Now A class, like I give an example, student class, student 2 class, landline number, those all immediately not possible. Just that's what A class, B class, like that. First you should understand concept. Okay. Now it's a class. Here X is a variable, X show is a method. Another class B extends A. Now integer y equal to 20. Void print. Now system dot out dot println B class. Now A class contains one instance variable, one instance method. B class also contains one variable, one instance method. Now this file name c.java, valid or not valid? This is starting session you learn. Starting sessions. Now file name c.java, valid or not valid? Valid. You can write. Okay. If it is c.java, how to compile? Java c.java. Then how many dot class file generated? 2. What are those? A dot class, B dot class. That is starting sessions you learn. Welcome program time. Okay. Now that is. Now suppose can I write B dot Java? Yes. If I write B dot Java, how to compile? Java C B dot Java. Okay. Then A dot class generated, B dot class generated. Whichever class contains main method, that class you have to use to execute. That's what main method I'll write here. Public static void main. Now if I save B.java, then compilation execution with B only, no? That's what I'll save with B. File save. B.java I'll write. Okay, just B. .java automatically takes save. Now this file name B.java. Okay, B.java I given. Now Java C B.java. Now if you have to compile Java C B.java, then two dot class file, A dot class, B dot class. Which class you have to use to execute? B, because B class contains main method. Now here you observe A OB equal to new A. If I write memory allocated to only A members, you can access X, you can access show. That's it. Suppose if I create BOB equal to new B, then A class members memory, B class memory also. Can access X show, Y print, all we can access. System.out.println ob.x. System.out.println ob.y. ob.show. ob.print. Now, if you write inheritance, then if you create again A class object, then writing inheritance is waste. Okay. Now that's what B object I created. When B object created, B is a subclass. Memory allocated to both superclass and subclass. Now ob.x, ob.y, ob.show, ob.print, all executed. File, save. See. Compilation, Java C, B.java. Execution, Java B. See, 10, 20, A class, B class, all printed. It is not completed. First you write the program. I have to explain with the diagrams. Write the complete program. I'll explain with the diagrams. In this program, which class object created? B class. B is superclass or subclass? Then memory allocated to both superclass and subclass. Both the classes memory allocated. Okay. Is it over? See, here, if I remove extends A, is there an inheritance? No. Extend keyword only inheritance in Java. Different programming language, different. Just because of extends A only, you are saying A inherited in B. It is single inheritance. But if you don't write extends A, then no relation between A class, B class. Both are individual classes, that type. So creating a new class based on existing class, that is called inheritance. Okay. Now here with the diagrams I'll explain. Here A class, here B class, A is superclass, B is subclass. A, B. A is superclass. Which contains X and show. B is subclass. B is subclass. Which contains Y and print. Okay. Now, first one, AOB1. AOB1 equal to new A. If I write. Okay. AOB1 equal to new A. If I write, now memory allocated to only A class members. X and show. X and show. It is A object. Here OB1. OB1 refers this object. Okay. Now here system.out.println OB1.x. Is it valid? Give me answer. Yes. System.out.println OB1.y. No. OB1.show. OB1.print. No. Okay. You observe. First, creating object like this valid, but calling like this valid, calling this one not valid, calling like this valid, it is not valid. Okay. Now second one, BOB2 equal to new B. If you create object, memory allocated to both A class and B class. A class memory allocated, B class memory also allocated. Okay. Both in a one object. This total memory allocated. It is which object? B object. This object referred by OB2. OB2. Now here I am writing one more circle to understand. It is A. It is not an object, only A. Okay, inner circle is not object. Now, if I write system.out.println OB2.x, is it valid? System.out.println OB2.y, OB2.show, OB2.print. Up to here, all are valid. These two, whatever I taught, two combination, very simple. Next, one more combination is there. That is how to teach. Write this one. First, you write this all. OB1. Okay. OB1, that is. So here only one object created. In that object, two classes memory allocated. Two class members memory. Okay, but inner circle is not a object. That's what I written only A. I didn't write A object. I written only A. Then you can identify these are A members. So identification purpose I written, that's it. This is which type of inheritance? Single inheritance. One superclass, one subclass. Which is superclass? A. Which is subclass? B. So this arrow will write like this only. This is superclass. It shows that superclass, parent class. Parent class, child class also will call. And the base class, derived class also will call. But according to Sun Microsystem specification, you have to call superclass, subclass. But different people, different type they are calling. Base class, derived class, and parent class, child class, like that also they are calling. If we create A object, only A members memory allocated. You can access A members only. That's what ob1.y error, ob1.print error. If you create B object, you can access B members, A members, B members. That's what all valid. Is it completed? Completed. Now you observe in this line, A class object created, A class reference created. In this line, B class object created, B class reference created. Okay. Now, third and fourth, two more combinations I'll give. Third and fourth, two more combinations. Now, A OB3 equal to new B. I'll ask question, give me answer. In this line, which class object created? A class or B class? Sure? A class or B class? B class, because object is right side. Object reference is left side. So here B object created, reference is created to A reference. It is A reference, it is B object. Right side object, left side reference. So B class object created, A class reference created. B class object created, A class reference created. Okay. Now you observe B class object. B is superclass or subclass. Then memory allocated to both. Both classes memory allocated. X show, Y print. Now okay. Now OB3. Now here carefully observe here. Here these all A members. These all A members. Okay. This reference is A type. A type reference, like a integer type variable, float type variable, character type variable, A type variable. Object reference can I call variable? Yes, you can call variable. Which type variable? A type variable. Reference variable only. A class also on data type. You already studied. Primitive data types, reference data types. You studied no? Reference data types are arrays, strings, classes, interfaces. So A is a class. A type variable, integer type variable, float type variable, like that A type variable. Now this A reference, it refers only A memory. Memory allocated for both. Memory allocated to A members and B members. But you can access only A members. Now this line is valid. This line is valid. Reason, in B object, A members are present or not present. That's what it will refer. That's what valid. This line is valid, and but it can access only A members. Suppose here system.out.println ob3.x. If I write system.out.println ob3.x, is it valid? Yes. System.out.println ob3.y, not valid. ob3.show, valid. ob3.print, not valid. So here it is valid. It is not valid. It is valid. It is not valid. But memory allocated, but we cannot access. Now this is third combination. One more I'll give. One more. Fourth one. B ob4 equal to new A. In this line, which class object created? A class. A class object. Then A class is superclass or subclass? Then memory allocated to only A class. Only A class, X and show. Okay. It is A object. Here ob4 created. Okay, ob4 created. It is which type? B type. Is there any B memory? That's what this line is not valid. This combination is not valid. Okay. Here, in this case, which object created? B object. In this B object, A members are present or not present? That's what it can access. It is valid. In this here, which object created? In this object, B members are present. That's what not valid. This combination is not valid. First, this line only not valid. Remaining calling also not possible. First, that line only error comes. Okay. Remaining all lines not valid. But again, this concept in polymorphism, I'll teach very depth. It is polymorphism, but inheritance requires polymorphism. Polymorphism requires inheritance. All mixed. Okay. That's what. Present only this one. Remember. Write this one. Over. Third one valid, fourth one not valid. Reason, in fourth one, A object created, in that object B members are not present. That's what not valid. But here B object created, A members are present. That's what you can assign. Is it completed? In four combinations, one is not valid. That is fourth one. That one we are not going to use now. Later we will see that one. That is explicit conversion, all those things possible. Present, that is not valid. That is leave it. First one we should not use. First one if you use writing inheritance waste, no. First one if you use. Second and third, which is better? Present, second better. Future, third also better. I'll explain. It depends upon situation. Present, second better. If it is third also, if it is not better, if it all which is better means that is depends upon situation. Depends upon situation. Sometimes second one better. Sometimes third one better. That it depends upon situation. Further it comes situations. Okay. Fourth one not possible. It's an error. It's an error present. Leave it. First one you should not write. If you write first one, writing inheritance is no use. Inheritance is wasted. That's what. Second and third. Now, whatever I given here, can I call this is variable? Can I call this is variable? Now, here object, B object assigned to A reference. Okay. Here A object assigned to B reference. Okay. Now, one question I'll ask, give me answer. Superclass object, superclass reference. I'll write one statement, valid or not valid, give me answer. Superclass reference can refer both superclass object and subclass object. Give me answer. Superclass reference can refer both superclass object and subclass object. Yes or no? How many people answer no? Next, how many answer right? Yes. No one is there. So majority wrong. See here, listen. That's what you observe here. AOB. It is the reference of which class? AOB. It is the reference of which class? A class. Equal to new A. Valid or not? New B. But refers no. I'm not saying accessing members. What I given? Superclass reference can refer both superclass object and subclass object. Here, superclass reference is A. AOB. It is the reference of which class? A class. Nothing but superclass. Okay. It will refer A object. Valid no? It will refer B object. Valid no? I am asking only refers. Superclass reference can refer both superclass object and subclass object. See, while giving answer, you think yourself. Don't depend on majority people answer. And suppose one person with louder voice, if they give right answer or wrong answer, that person voice also don't follow. Like that also don't follow. Your answer right or wrong, whatever it may be, think and give answer. Everyone should think and give answer. Okay. Your answer right or wrong, leave it. You try to think and give answer. Don't depend on majority people answer. Okay. Now, superclass reference can refer both superclass object and subclass object. Is it right or wrong? Right. But it can access superclass members only. Got your point? Got your point? A class, in that example, A class reference refers A class object and B class object, but we can access only A members. Okay? Now, write this one. AOB equal to dash. New A or new B. AOB equal to new A or new B. So giving answer is important. Answer right or wrong, leave it. Okay, that is important. That is important. And also confidence. Louder voice also required. Hand is like this, like that's only required. It is only better. Sometimes with confidence level also you'll get a jobs. That's what confidence level is important. Sometimes what will happen with your confidence also they make you a job. Chances are there. What they'll think is if I give a chance, he can learn, he can perform, he can do it like that. They'll think they'll give a chance. That is the reason giving answer confidently is better. Okay. Superclass reference, that means A class reference in that example. Superclass reference, nothing but A class reference, can refer both superclass object and subclass object. So new A valid, new B valid, but it can access superclass members only. Referring is different, accessing is different. Now it is called referring, but accessing, can we access B members? No, only A members. Okay. Now, same style, give me answer, subclass reference. Same style, what it will refer, what it can access. Give me answer. That superclass reference place, subclass reference. Now give me answer. Subclass reference can refer. Same means same, don't copy. Same means same, don't copy. Answer, right answer. Subclass reference can refer only subclass object. But it can access both superclass and subclass members. Got any point? This is different, that is different. See, is it over? No. Now here, now subclass reference can refer, subclass reference can refer only subclass object, but it can access both superclass and subclass members. That means here B reference, what we can write here? Can I write new A? No. Can I write new B? Yes. That's it. New B. So it is new B only valid. But can I access A members? Yes. A members we can access. B members we can access. That is right. This one. A OB equal to new A, new B valid, but B OB equal to new B only valid. But we can access A member also. See, somewhat confusion is there, but I given clarity. Okay. Confusion questions only interview questions. Complicated questions only interview question. On that only you have to focus more. A class now according to this super subclass means here A is superclass, B is subclass. First you complete. Now I given notes superclass subclass concept. Suppose in that example, A class reference can refer. A class reference can refer A object, B object, but it can access A members only. B class reference can refer only B class object, but it can access both A members, B members. Is it clear now? Clear? Now. Say. Not over. Not over. Just only new A. BOB equal to BOB equal to new B. New B only can write. Say. Now present. I'll remove this. I'll remove this. Now you observe A class contains one instance variable. B extends A. Inheritance is there. Okay. Int Y. Here. Int Z. Now here which class object created? Memory allocated to A and B. X memory, Y memory, both allocated. OB dot print. This print method called. Then local variable memory also allocated. Now here system dot out dot print ln X. System dot out dot print ln Y. System dot print ln Z. Okay. Now X and Y, which type of variables? How many ways to access? What are those? Z, which type of variable? How many ways to access? That is, now give me answer here. These all are valid or not valid? Give me answer. Only Z valid? All are valid? All are valid? Sure. X and Y, how many ways to access? What are those? But how it is valid? This keyword implicitly present. Okay. This keyword doesn't appears to you, but it is there. That's what valid. Okay. This is this keyword. File, save. All are valid. Okay. Say compilation, execution. All are valid. Write this one. These are just examples, no? So up to exception handling topic, every class important. Be regular, put efforts, work hard to understand. Here B object created, memory allocated to A and B. X memory allocated, Y memory allocated, these two in B object. B object. This object referred by OB. Here, this is A member. This is A member. Here, implicitly, this dot X, this dot Y. This dot X, this dot Y. These all implicitly. It doesn't appear to you. Here, this keyword refers current object. Same object. Z is outside local variable. Z is outside local variable. I return X only. That is implicitly this dot X. I return Y. Implicitly this dot Y. This dot X, this dot Y. This keyword refers current object. See, B object created, B reference created. A memory allocated, B memory allocated. This object reference refers entire object, complete object. That is with this keyword we can access. That's what this dot X, this dot Y. Both are valid. Both are valid. Z local variable, just directly Z. I return X only, but implicitly this dot X. I return Y, implicitly this dot Y, but it is Z only, not implicitly this dot Z. That is only Z. This keyword also refers complete object. That's what A members, B members, all you can access. Is it over? Now, see, myself, I'm writing this dot X. Any effect? Here also this dot Y. No. No effect on program. Say, same output. Okay. Suppose here I'll write this dot Z. Will it compile? No, error comes. Error. There is no instance variable Z. It is searched as an instance variable. Not there. Error. So here this not there. Here this is there. That's what compiling. Okay. Now, suppose this variable name also X. Then what will be the output? What will be the output? 30. Now 30. It is 20. How to print 10? This dot X explicitly required. We outright this keyword. Okay. So if I write this dot X, then 10. Okay. Suppose this is Y. This is Y. Here only X. What is the output? 10. Here 30. How to print 20? This dot Y. Okay. Now Suppose it is also x, it is also x, then x 30. Next, this dot x, what is output? 20. Now, if local variable name, instance variable name, if it is same, if you want to access instance variable, this keyword required. Suppose this variable name is y. Here this dot x means 10 printed. This variable name same. You can access this one by using this. But it is also this means 20 printed. In this situation, if you want to print 10, we have super keyword. Now, before going to this program, first you write super keyword. Super keyword. It is called as an object reference or reference variable because it refers superclass memory. It is called as an object reference or reference variable because it refers superclass memory. It is called as an object reference or reference variable because it refers superclass memory. You studied this keyword. What is this keyword? Object reference or reference variable. Why we are calling like that? Because it refers current object. But here, not object, only superclass memory. Superclass memory only it can refer. Using this keyword, say you have seen. Suppose this variable name is y. If I write here, this is x, this is y, this is x. Here, what is output? What is output? Here, 10. So using this keyword, superclass memory also can access. Okay, but using super keyword, superclass memory only possible. That's the reason like this. Using this keyword, subclass memory, superclass memory, all you can access because that refers current object. In an object, whatever is there, all you can access. But it will refer only superclass memory. Okay. Now I'll give with a diagram. Now it will not come implicitly. It is explicitly we have to write. It is explicitly required to access superclass member whenever both superclass member and subclass member names are same. It is explicitly required to access superclass member whenever both superclass member and subclass member names are same. It is explicitly required to access superclass member whenever both superclass member and subclass member names are same. Here, member can be a variable or method. Here, member can be a variable or method. Here, member can be a variable or method. See, it is explicitly required. When it is required, superclass member, superclass member, subclass member, names are same. Implicitly it will not come. If implicitly not required also, because this keyword only can access. Now, here member can be a variable or method. Okay. Now, here superclass member, subclass member, if names are same, in this situation, super keyword required. Here what is output? Here what is output? 20. Here, in this case, 10. So 30, 20, 10. Compilation, execution. Write this program. Example 1. Example 1. Here, B object created, memory allocated to A as well as B. This is also X, it is also X, local variable also X. B object referred by OB. Now, first you write the program only. Write the program. Diagram I'll explain. Diagram I'll explain. Just write the program. Is it completed? No. It is which class object created? B class. B is superclass or subclass? Memory allocated to both the classes A and B. That object referred by OB. Like this allocated. Now this keyword. What is this keyword? Object reference. Refers complete object it can access. A members also it can access, B members also it can access. But here also X is there, here also X is there. That's what it will print 20. In this case, we required super keyword. Super keyword, what it refers? Only superclass memory. Only superclass memory it refers. Now, using this keyword, my question, listen. Using this keyword, can I access A members? Yes. Using super keyword, can I access B members? No. Super keyword, only superclass memory. This keyword and complete object. So this keyword different, super keyword different. This keyword refers entire object, complete object. So variable name same is there. That's what super keyword required. Variable name different is there. A class members also you can access with this keyword. But with super keyword, you cannot access subclass members. That is only for superclass. Okay. Write this one. Variable name same is there, then only required. Different is there, not required. Write this complete diagram also. This keyword refers complete object. That means superclass members, subclass members. But super keyword refers only superclass. Yeah. Is it over? We'll see continuation tomorrow.